Hello, guys. Welcome to Mathematics class with Mpatele TL. And hopefully you are enjoying our lessons. Hopefully you are finding my lessons to be very, very useful. So in today's topic, I want us to look at exponential functions. So let's go through the exponential functions here. Okay. Let's talk about the exponential function. Exponential function. So I want us to explore some key ideas about the exponential function. One thing that takes my attention now, we have to talk about the inverse of the exponential function. How do we find the inverse of the exponential function? So I'm going to say, okay, this side, let me have a function which is going to be exponential function. On this side, on the right side, let me talk about the inverse of the exponential function. So on the left, I'm talking about the function itself, the exponential function. Let me give an example of the exponential function. Let me say f of x is equals to 3 to the exponents x. So we have the exponential function f of x equals to 3 to the exponent x. How do I know that is the exponential function? Because the variable x there is the exponent. So f of x equals to 3 to the exponent x is the exponential function. Now, the first thing I want us to go through is to determine f to the exponent -1, meaning that determine the inverse of the exponential function. So how do we find the inverse of the exponential function? And this one is a typical exam question. So you need to be very, very prepared about the inverse of the exponential function. So the first thing that I want us to go through is how do we find the equation of the inverse? Given the function, how do we find the inverse of a function? Okay, so let's go through it. We're going to determine the inverse. They prefer to say in the form y equals to. So they say we want the inverse of the exponential function, put it in the form y equals to. Okay. Typical me, I prefer to have a drink when I'm doing something very, very, very important. Actually, this habit came when I'm studying. When I'm doing maths, I prefer to have a cup of tea with me. So that habit now, it has grown. Even when I'm teaching maths, I need a cup of tea. Okay, so how do we find the inverse of a function? So our first step, our step 1 is to interchange x and y. One can say swap. So we are going to swap the two variables. We are going to swap x and y. In the position of x, we are going to put y. In the position of y, we put x. So let us write down the equation first, the one that we are looking for, its inverse. It's y equals to 3 to the exponent x. Remember, I said this f of x represent y. So y equals to 3 to the exponent x. So my first step when I'm looking for the inverse is to swap. So on whether it's y, I put x. X equals to 3. Whether it's x, I put y. So my first step was to swap x and y. Okay. Now, actually, this x equals to 3 to the exponent y. It is the inverse of f. It is the inverse of that function, f of x equals to 3 to the exponent x. It is the inverse, but it is not in the form preferred by the examiners. So they want it to be in the form where y is the subject of the formula. Okay, so x equals to 3 to the exponent y is the inverse of f, but we still need to do something to it. We need to put it in the form where y is the subject of the formula. And there is something that I do here. Okay, I normally say what is written in exponential form can also be written in a logarithm form. So now I'm going to say, okay, how can I write this x equals to 3 to the exponent y in a logarithm form? How can I put it in a log form? So I'm going to say, okay, my base is 3. Next to the base, I will say log of that. You see, nearly to the base, just before the base, I put log. I say log, and here I'm still having my equal sign. So what's happening now? I'm going to interchange again where there is this x, I now put y. Where there is y, I now put x. So y equals to log x base 3 is the inverse of y equals to 3 to the exponent x, is the inverse of this function. F of x equals to 3 to the exponent x. So f of x equals to 3 to the exponent x is the same as y equals to 3 to the exponent x. So what is the inverse of y equals to 3 to the exponent x? It has got two guys. One of the inverse is x equals to 3 to the exponent y. It is the inverse, but not in a preferred form. In a preferred form, we want y to be the subject of the formula. Another inverse of the same thing it's actually not another inverse. Is the inverse written in a log form, which is what? Y equals to log x base of 3. So what is the inverse of y equals to 3 to the exponent x? It is x equals to 3 to the exponent y. It is y equals to log x base 3. Both these, they are the inverse. Actually, we say these two guys, this guy and this guy is the same. This is one thing, is just the difference is due to the way it is written. One is written in an exponential form where the subject of the formula is x. The other one is written in a logarithm form. Now, that is why we say the exponential function and the logarithm function, they are the inverse of each other. So now, if I ask you to sketch the inverse, which is very, very, very important now, you must be able to find the equation of the inverse and also be able to sketch the graph of the inverse of a function. Okay, so let me say, okay, I'm going to do this. Let me erase here. Firstly, I want us to sketch the function y equals to 3 to the exponent x. Y equals to 3 to the exponent x. Y equals to 3 to the exponent x. I want us to sketch this function. Okay? Now, y equals to 3 to the exponent x, what is its inverse? Is y equals to log of x base 3. So this is the inverse of f. In this case, it's going to be f to the exponent negative 1. So now I'm saying, okay, if they ask you to sketch the inverse, you can do this one very easily by looking at original function. You can even not touch this inverse. Y equals to log x base 3. You can still not touch it, but still be able to sketch the graph of this function here. Okay, so before I even sketch the inverse, let me show you how do we sketch this one. Y equals to 3 to the exponent x. This is our original function. It's not the inverse. So I want us to sketch y equals to 3 to the exponent x and later sketch y equals to log x base 3. So we are going to later sketch the inverse of a function. Now, here I can say table method will still work. Actually, this is the method I remember very well I used when I was in grade 12. In this case, the table method can work very well to sketch this exponential function. How say? I'll say, okay, x and y. Remember, your x are your input value. Your x are the values that you put in. So I'm going to say, okay, when x is negative 2, I'm just creating these values negative 2. They are my input values. So I'm saying when x is negative 2, what is the value of y? Okay, when x is negative 2, y is going to be 3 to the exponent negative 2, meaning that where there is x, we put negative 2. We are saying x is negative 2. Therefore, y equals to 1 over 3 to the exponent 2. I am intentionally teaching you this one. We are saying if the exponent is negative, we can write it in such a way that the exponent become positive. If you have got 3 to the exponent negative 2, you can write this as 1 over 3 to the exponent 2, which is 1 over 9. So 1 over 9. So when x is negative 2, y it's 1 over 9. And when x is negative 1, you will confirm it, y it's 1 over 3. When x is 0, y it's 1. When x is 1, y it's 3. When x is 2, y is 9. So, okay, let me erase everything and write it neatly as a table. So I'm saying when, okay, when x is negative 2, y is 1 over 9. When x is negative 1, 1 over 3, 0, 1, 1, 3, 2, 9. So now you do this. This is your table. You have a table of x values and y values. Now, okay, let me pull this table a little bit up. I need space. -2, -1, 0, 1, 2, 1 over 9, 1 over 3, 1, 3, 9. When our input value are this one, these are our output values. Now, I want us to sketch. Remember, this is the y equals to 3 to the exponent x. This is y equals to, we are sketching y equals to 3 to the exponent x. We show the y-axis. We show the x-axis. Now, very, very important. This function that we are sketching, which is y equals to 3 to the exponent x, you have to recall that it has an asymptote. It has an asymptote. Actually, the y asymptote. The y asymptote. So the exponential function, it has got only one asymptote, which is the asymptote of y. And in this case, we have to check what is the y asymptote. Our equation is y equals to 3 to the exponent x. So if you have got y equals to 3 to the exponent x, this is our base. 3 is our base. X is the exponent. So somewhere here, normally here, there will be a number here. In this case, because we don't have a number here after the base and the exponent, we just say it's 0. And it means that the y asymptote, in this case, it is 0. So the equation of the y asymptote, it's y equals to 0. Okay? For you to understand the idea of the y asymptote, I'm going to put the number. Let's say maybe you have a function like this one. Can I write here? Oh, yes. Y equals to 3 to the exponent x minus 1. If you had something like this, y equals to 3 to the exponent x minus 1. Your y asymptote, this exponential function has got the y asymptote. Your y asymptote is this number at the end. And what is this number at the end? Is -1. And that is your y asymptote. So it's easy to see the y asymptote, guys, in exponential function. Please, please, please. If you've got y equals to 3 to the exponent x, maybe plus 4. This plus 4 is going to be your y asymptote. Now, if you have y equals to 3 to the exponent x, what is your y asymptote? It is 0. We say we don't have any number here. So the y asymptote is 0. So back to this function, y equals to 3 to the exponent x. What is its asymptote? It's 0. The y asymptote is 0. What do we mean actually? We are saying when y is 0, there is no value of x that can map to y being 0. For example, here, we are saying when x is 2, y is 9. When x is 1, y is 3. But we are saying we don't have a value of x that can give us the output value of 0. So we don't have any value of x that maps to y being 0. So we say, okay, y being 0, it is the y asymptote. There is no value of x that can give us the y of 0. So now, when we draw this graph of y equals to 3 to the exponent x, we need to show the asymptote first. And we are saying, in this case, we are saying the asymptote is 0. And we know that 0 is here. So when you show this y asymptote, what is very important now is to recall that the y asymptote is a horizontal line. So your y asymptote is going to be a horizontal line. So let us show you the y asymptote will actually lie exactly on the x-axis. This is where we put our y asymptote exactly on the x-axis. This is where we find the asymptote of this graph, y equals to 3 to the exponent x, meaning that the graph will not touch the x-axis because we have a horizontal asymptote on the x-axis. So when we draw this graph of y equals to 3 to the exponent x, it's not going to touch the x-axis, which means that we don't have the x-intercept. We don't have the x-intercept. So now let us sketch it. Okay, I will say when x is 0, y is 1, putting a point here. When x is 1, you can see it. When x is 1, y is 3. So 1, 2, 3. Y is 3. So I already have 2 points. I'm lazy to show other point, which is going to be 2 and 9. Maybe somewhere there on top, 2 and 9. So another point is going to be here. So the graph will be coming like this. You can also show when x is -1, y is 1 over 3, which is 0.33 something. You will check it with your calculator. So another point will be here. So if you keep putting the point, the graph will go like this. It won't touch the x-axis. So this is the graph of y equals to 3 to the exponent x. So this is the graph of y equals to 3 to the exponent x. Now, if I ask you, now you have sketched the function y equals to 3 to the exponent x. What if I ask you to to sketch its inverse? I want you now to sketch the inverse of y equals to 3 to the exponent x. Here we have sketched the function y equals to 3 to the exponent x. What about if I say sketch its inverse? Okay, we know the equation of the inverse. Y equals to log x base 3 is the equation of the inverse. But when you are sketching this one for now, I can even say, don't touch this one. You can even ignore it for now. Why? Because I will show you a strategy that you can use to sketch the inverse of a graph. What you are going to do, you are going to say, okay, what was the asymptote here? We had the y asymptote. What was the y asymptote? It was y equals to 0. The equation of the asymptote, the y asymptote is 0. Now we say, okay, if the original function had the y asymptote being 0, it means that the inverse of a function will have an x asymptote. What? Didn't you say the exponential function has got only one asymptote, which is the asymptote of y? Yes, the exponential function has got one asymptote, the asymptote of y, but the inverse of the exponential function will have it will be, in this case, its asymptote. What was the y asymptote will now become the x asymptote in the inverse of a function. So it means that the x asymptote is going to be, the equation of the asymptote is going to be x equals to 0. I don't think I've explained this well. Let me come down. Maybe let me have a drink. Okay. I'm saying whenever the original function has the asymptote of y equals to 0, it means that the inverse will have the asymptote of x equals to 0. So I'm going to take the information from the original function and use that information to sketch the inverse. Okay? Actually, what was y will become x. So in this case, I will say, I can be able to show you the table now of this of this inverse. What is going to be? I'm going to swap now. I'm going to say, okay, swap the values. I'm going to say 1 over 9, now minus 2. 1 over 3, do you see what I'm doing? I'm swapping the values. Minus 1. 1, 0. Okay. 3, 1. 9, 2. What was y become x. What was x becomes y. So you just swap your coordinates actually. You just swap your coordinate, then you will be easily able to draw the inverse of y equals to 3 to the exponent x. Let's say you have the y-axis and you have the x-axis. I want to sketch. Now I know I have the asymptote of x equals to 0. So it will be a vertical asymptote. It will be like this. Okay? Now you can map your coordinates. You map y being negative 2. I want to map this ones this side. You map x being 1 with 0. I think it's here. The point it's here. You map x being 3 to 3. X being 3 to 3. 3 maps with 1. 1. And then you have got 9 mapping with 2. So you'll have 4, 5, 6, 7, 8, 9. 9x is 9. It maps with y of 2. So the point will be here. Okay, let me just, remember I'm not drawing to scale. Maybe it might be something like here. Let me see, let me just put 2 here. So the point, forget this one, it's going to be 9 and 2. The point is here. So the graph goes like this. It should not touch the y-axis. It should not touch the y-axis. So the graph goes like this. I'm failing to avoid touching this y-axis. Yes, so this is the exponential, the logarithm function. This is the graph of y equals to log x base 3. So I just swapped the coordinates. It's easy actually to sketch the graph. You swap the coordinates. And one thing again that I want us to talk about is the domain of this graph, the domain and the range. What is the domain of this exponential function? What is the domain of this y equals to 3 to the exponent x? So this one you need to observe your graph carefully. We say x is the element of all real numbers. So you look at the graph is continuous. Look at this graph here. Look at this graph. It's continuous in this direction, and it's also continuous in this. It's continuous to the left and continuous to the right. So we say the domain of this exponential function, the original function, not its inverse. The domain of the original function, we say x is any real number. If you are looking for the domain of the exponential function, all exponential functions, they have the domain of x is the element of real number. So we say x can be any real number. Okay, you still remember the definition of a domain. We said the domain is the set of values of x for which the function is defined. So y equals to 3 to the exponent x. It is defined for all values of x, meaning that for all values of x, whichever value of x you pick, you will be able to find the output value. You'll be able to find the value of y that maps to the x you have picked. So the domain of this one is x is the element of real numbers. So that is why most of the time we don't ask you to give us the domain of the exponential function, because we know that the domain of the exponential function is very easy. X is any real number. But now you have to watch out. If I go to the inverse, this is the domain of the original function. If I go to the inverse of this y equals to 3 to the exponent x, which is y equals to log x base 3. If I ask you to find the domain of the inverse of this one, what is going to be the domain? You'll realize that, okay, what was the range in the original function will become the domain. Okay, let me say, what am I doing? Let me say domain. Okay, let me go back to this original function, y equals to 3 to the exponent x, and say what is its range. The exponential, this one, the original function, what is its range? We say y is greater than 0. So actually we say y is the element of all real numbers such that all values of y are greater than 0. You can look at the exponential function, this one. The graph is above the this asymptote, the equation of asymptote y equals to 0. The graph is above the x-axis. So above the x-axis, all values of y are positive. So we say the range of this function y equals to 3 to the exponent x. The range is y is greater than 0. So we are saying all values of y are above the x-axis. And you can see the graph, it's above the x-axis. All values of y are above the x-axis. So you say y is greater than 0, which means that now if I ask you to find the inverse, okay? I mean, if I ask you to find the domain of the inverse of y equals to 3 to the exponent x, the domain is now going to be x is greater than 0. You still there. What was the range will become your domain. But when we write the domain, we cannot talk about y. I cannot say my domain is y is greater than 0. What I can say, I will say, okay, it means that the domain, it is x is greater than 0. And what is the range of the inverse? The range, you pick the ideas from the domain of the original function. What was the domain in the original function? Now give us the range. What is going to be the range? The domain was x is the element of real number. So the range is y is the element of real number. So now, okay. So guys, actually when you are looking for the domain of the inverse, you have to ask yourself, what was the range of the original function? Because the range of the original function will give you the ideas, will give you more information about the domain of the inverse. If we ask you to find the range of the inverse, what was the domain in the original function will give you ideas about what is the range of the inverse. What was the domain? Give us information about the range. What was the range? Give us the information about the domain. So on my left-hand side, I'm looking at the original function. On my right-hand side, I'm looking at the inverse of a function. Okay? Hopefully, we are making sense. Hopefully, we are making sense. So another thing now that I want us to go through, let me erase. Let me erase and do. I want to ask you one of the interesting question. One of the very interesting question, typical question that examiners love. Okay, the first one that I want us to look at is this one. Let me say I give you a function, f of x equals to log x base a. So I'm giving a function f of x equals to log x base of a. Now, this is the function on the sketched graph. I think it's going to be something like, it won't touch the y-axis, something like this. Okay, so it is this graph of f of x. And you have to know, okay, when we say f of x equals to log x base a, just know actually this function is the inverse of a certain function. Actually is the inverse of, okay, is the inverse of y equals to a to the exponent x. This, once you see, when we give you a logarithm function, you have to know that this log function obviously is the inverse of an exponential function. Which exponential function? In this case, we are referring to y equals to a to the exponent x. So these are the two graphs which are the inverse of each other. Now, I want you to find Let me say, I want you to find the coordinates of a point A. If I was to say at this point A, suppose X is, okay, suppose X is 2. Find the Y coordinate. So I want you to find the coordinates of A. I gave you the X coordinate. So I want you to find the Y coordinate. Okay, in this case, it won't be possible because I did not give you the value of A. So let me say we have got log X base of 3. Yes, instead of using variable A, let me say f of X equals to log X base of 3 and ask you to find the coordinates of A. What is going to be the coordinates of A? Okay, you know that X is 2, you have to find Y. So now what you do, you have f of X equals to log X base 3. So what I want you to do, I want you to avoid working with a log function. So you firstly, before you do anything, you simply say, this log function, I can write it in exponential function. You are not looking for the inverse of this f of X equals to log X base 3. You are just saying, what is written in a log form? Let me write it in exponential form. So I advise you to work with an expression of exponential form. Don't work too much with logarithm. So from log form, turn it into the exponential form. So we say this is the same as where there is y, you put x. So you say x equals to, your base is 3. So you say 3, where there is x, you put y. So we say these two things, it's one thing. This is the same thing written differently. One is written in a log form. The other one is written in exponential form. So these two things are the same thing. So you have f of x equals to log x base 3, which is the same as x equals to 3 to the exponent y. So now it will be easy to find y if we work it when it's like this. Okay? What did I say? It is x. I set my x, it is 2. Let me say my x, it is 9 actually. Instead of saying x is 2 as keys, let us use 9. So let's say at the point A, our x is 9. So now we're going to try to find y. Where we see x, we put 9. So 9 equals to 3 to the exponent y. Then you solve for y. 9 can be written as 3 to the exponent 2. Actually, that is why I said let us put our x to be 9 so that we can be able to have the same base. We have the base of 3. So what is the value of y? It is 2. So y is equals to 2. So it means the point of A, it is 9 and 2. Bear in mind that my diagrams are not drawn to scale, guys. So hopefully you have learned a lot about this exponential stuff. One other question that they like is to do something like this. The last question, they do this. Then they sketch a graph like this. They say, give us the coordinates of A, or let me call it B. Give us the coordinates of B. They say f of x equals to a to the exponent x. So they say f of x equals to a to the exponent x. What are the coordinates of b? Okay, you know that b is the y-intercept. B is the y-intercept. Why do I say b is the y-intercept? Because it's seated on the y-axis. B is seated, this point B, it is seated on the y-axis. So your B is the y-intercept. And how do you find the y-intercept? You let x to be 0. So you're going to say f of x is 0. I'm using this equation. Equals to a Where there is x, you put 0. A to the exponent 0, it's 1. So it means y is 1. So the coordinates of B is 0 and 1 in this context. Thank you so much, guys. See you next time. Keep visiting my YouTube channel. This is where we look at mathematics. Thank you. Keep well. God bless you. I'm going to end this lesson.